Swayam Prabha. Digital India. Educated India.
Hello everybody, welcome to the course Reactive Intermediates, Carbenes and Nitrenes. So, today we are going to discuss a very important part of this topic, that is called nitrene. This nitrene also similar to the carbene, very much reactive, and they are short lived, and in general all the different aspects of these nitrenes are almost similar like a carbene. Okay. So, today what we will start then, that is called nitrene. So, this reactive intermediate are actually nitrogen analog of carbene. So, this one is the nitrogen analog of carbene. Okay. So, we know that carbenes are short lived species and they are very much reactive. Similarly, these nitrenes are also very much short lived in general, and they are also very much reactive species. Now, if we see their electronic structure, so in general they could be this, or they could be like this. Now, this is called singlet nitrene, and this is called triplet nitrene. If we say that nitrogen is having their own lone pair, that is this one, that is the normal paired lone pair, this is the normal paired lone pair, okay. Here also the same thing, whereas there are these two electrons are there that either could be paired up or they can stay like this as a triplet nitrene. Okay. So, in general what are these R? These R are could be alkyl, okay, acyl, phenyl, carboalkoxy, etc. Okay. So, if we see that this species, this reactive intermediate species, that is nitrene, they are like a singlet or triplet, and they are nitrogen analog of the carbene, where their R could be alkyl, acyl, phenyl, etc. Okay. So, what are their characteristics? As I mentioned previously, that they are the nitrogen analog, we can say, of carbenes. So, they are neutral species, and obviously they are monovalent nitrogen species, having 6 electrons. Okay. Okay. And they are isoelectronic with carbenes, because in case of carbenes also we found they are highly electron deficient species, they are having only 6 electrons. Similarly, nitrines are also same, they are also isoelectronic with carbenes, they are having this 6 electrons with them, and obviously they are highly reactive species. Okay. Generally short lived, okay. And with this, all these characteristics for these nitrines are actually matching with carbenes, but still there are certain aspects or certain reactivities that is different than the carbenes. Why it is like this, we will discuss that also. Okay. So, now we will see the structure and hybridization of nitrine. So, structure and hybridization of nitrine. Okay. We have seen in case of carbene how they are like a triplet and singlet, what are their hybridizations, how they are staying like a sp2 singlet or triplet, and what are their what will be their bond angles, those things we have discussed. Here for this particular nitrine species, as they have also 6 electrons with them. So, in general these nitrines they are having this either triplet sp or singlet sp2 type. Okay. So, now we have total 6 electrons with them. So, now one is this bonding one pair of electrons, now another 2 electrons, that is the these are the nitrogens, that lone pair that could be there, and that 2 valence electrons, they will stay almost nearly degenerate non bonding molecular orbitals, they will stay in their parallel spin. So, these 2 valence electrons they wanted to stay in these non bonding molecular orbitals, okay, in parallel spin. Okay. So, these 2 electrons they will stay in this non bonding molecular orbital. Okay. What about this one? This is sp triplet. Okay. They are sp hybridizations and this is a triplet because both are unpaired electrons and they are with the parallel spin. Now, another possibility that nitrines are generally staying as a sp2 singlet, this non bonding p orbital, and here they can be these 6 total electrons, one is 2 are here as a bonding electrons, then these 2 are lone pair electrons, they are also paired up, and another 2 electrons they can be paired up and stays here. So, that there will be in a singlet state. So, this one we can say that sp2 hybridized nitrine, the center is sp2 hybridized and then sp2 singlet. Okay. So, in this case these two nitrines, one is sp hybridized, another one is sp2 hybridized, and in this case two unpaired electrons are there in parallel spin, they are, that is why sp triplet, and in this case these electrons, two electrons, unpaired electrons become paired up and they stays like a, this nitrogen here, this center is sp2 hybridized and that is in a singlet state. Okay. In general, it has been found that nitrines are generally linear, and it has been found that triplet state, that is this one, triplet state is lower in energy than singlet state. Okay. So, in the ground state, this is their triplet state, that is lower in energy than the singlet state. Okay. Now, once this type of nitrine formed, okay, like triplet nitrine or singlet nitrine, in case of triplet nitrine, which actually behaves like a biradical, okay, behaves like biradical. Okay. We have seen in case of carbene also, where it is triplet carbene, that time also we have mentioned that in that case that triplet carbene, that also act like a what, biradical. Here also this triplet nitrine, they can behaves like a biradical, and as that is unpaired electrons are there. So, in that case obviously spectroscopically these can be again understood, or this can be again this can be by experimentally this can be examined, okay, whether this triplet nitrine has formed or not. Through spectroscopy also we can measure for this triplet nitrine. Okay. Now, what they will do as a biradical, what type of reactions they can do? This can actually do hydrogen abstraction reaction, okay, or similar like a carbene. We have seen that in case of carbene also, when it is triplet carbene, we have mentioned that when it is adding to any pi systems, most like the double bond or olefins, that is giving the non stereo specific additions. That means, after addition of this triplet carbene, what happens? There is, it is not stereo specific anymore. That means, we are getting mixture of products. In this case also, when we have used the triplet nitrine, they also behaves in similar mode of fashion, that is they will also give non stereo specific addition to pi systems. Okay. Or else, as it is also like a behaving like a diradical, that can also added to another radicals. So, addition to radicals, okay. Or these two nitrines, they can dimerize themselves. So, another reactions can be possible from these triplet nitrines, that is the dimerization of the nitrines to provide the azo compounds. Okay. So, this different type of reactions can be possible with the triplet nitrine, okay. And we have seen that this is also working in a similar fashion like carbene. Okay. Now, singlet nitrine, what will be their reactions, what kind of reactions they are proceeding. So, if we take singlet nitrine, we can write here or here we can write, okay, sorry, some mistakes. Okay. Now, the singlet carbene, like singlet carbene, singlet nitrene also behave in similar way. One important aspect for this singlet nitrene is that it is having one empty non-bonding molecular orbitals. Okay. This has what? One empty non-bonding molecular orbital, and that has capability to accept electrons from other sources. So, in that case this type of singlet nitrene, they actually behaves like electrophile. So, behaves like electrophile. Okay. We have seen even though they are analogous to carbene, but due to their structural features, that nitrenes are actually giving different type of reactions than the carbenes, because of their structural aspects. Okay. So, in that case, if this singlet nitrene is behaving like a electrophile, so what type of reactions they can give? That in general the singlet nitrenes, that obviously this is a sp2 singlet nitrenes, and then they will give similar like a carbene type of addition reactions, and that is obviously in a concerted manner. So, whether this is insertion into carbon hydrogen bond, or whether that is insertion into sorry, not addition into some pi bonds, all will be stereo specific. So, we can think about that this will give concerted carbon hydrogen insertion, okay. Next it can give stereo specific addition to pi bonds, okay. Or as this is like a working like a electrophile, that means this is having some empty non-bonding orbital. So, in that case the nucleophiles can also attack to the nitrenes. So, we can write that addition to nucleophiles, okay. Or there could be similar like a carbenes, here also it is possible to shift that 1 to sigmatropic shift. And obviously, this type of sigmatropic shifting will lead to different type of rearrangement reactions, which we will discuss during our reactions and rearrangement part of this nitrene. Okay. So, overall what we have seen that even though these nitrenes are the nitrogen analog of the carbene, they are the isoelectronic, but with the carbene, but still due to their structural features they will have certain different type of reactions or reactivity. In one case triplet nitrene, that is the in general that is sp triplet nitrenes, they behaves like a biradical and gives different type of reactions like dimerization, hydrogen abstraction, non-stereo specific addition and addition to radicals. This is important that here these triplets will give these non-stereo specific additions, okay, whereas this is stereo specific additions. This is similar like a carbene. Additionally, what we said that these triplet nitrenes, they can be understood through some ESR spectroscopy. Okay. Now, next what we will see that how these nitrene stability, okay, differ with the substitution on the nitrogen. Okay. So, if you put substitution on nitrogen, that actually and one specific type of substituents that actually stabilize these nitrines, and it is possible to detect these even though they are very much short lived transient species, but reactive species, but this could be actually stable in solution at low temperature. Okay. So, it can be detected through various spectroscopic technique as per the infrared spectroscopy. Okay. So, if we now put the substituents on the nitrogen, that what will change, that affects the multiplicity, okay, and obviously electrophilic reactivity of nitrine. Okay. So, in general that affects the multiplicity and the electrophilic reactivity. Okay. If we take, as per example, if we take some strong pi donor substituent which could stabilize the singlet ground state, okay, singlet ground state of this nitrine. So, if you take this strong pi donor substituent, okay, then what that will stabilize the singlet ground state of nitrine. Okay. So, we will take one example, like if we use 1 amino 2255 tetramethyl pyrrolidine, that is this molecule, this is a pyrrolidine moiety and this is 2255 tetramethyl pyrrolidine, and if we take its 1 amino 2255 tetramethyl pyrrolidine, this substrate, then under oxidation condition what will happen if we oxidize this. So, basically that will generate the nitrine, and okay, it will be stabilized, and this is a singlet state that generates, okay, and this is actually in resonance So, initially this nitrine will generate, okay, and this could be in resonance with this species, that is this is called 1,1-diazine. Okay. So, this is the 1,1-diazine that will be formed and it is stable in solution at low temperature. So, this is stable in solution . Okay. So, what happens? We took this 1 amino 2255 tetramethyl pyrrolidine, this is called 1 amino 2255 tetramethyl pyrrolidine, and if we take this and oxidize this, that will form this 1,1-diazine species, and this is the nitrine species that could be stable in solutions at low temperature. Because of this is having this nitrogen among this nitrogen here, this is the substituent that is actually stabilizing this unstable reactive intermediate nitrine here. Okay. And in principle these species actually could be visualized through IR spectroscopy. One spectroscopy is there, through that we can actually visualize different type of, whether that some organic molecules has formed or not, or some due to some stretching frequency of that typical bond, we can understand that whether that functional group is present or not. through this particular spectroscopy. So, this is called IR spectroscopy, and in this through this we can actually, here nu max is around 38 centimeter inverse. Okay. So, due to this bond. Okay. So, through IR it can be visualized and it can be detected. Now, what are the applications? Of course, the nitrines are generating, and what will be their applications in various type of reactions. So, if we see their applications, in case of triplet nitrine, as they are having these unpaired electrons and they are behaving like a biradical, they could be a very good species for as a organic magnetic material. So, they can be used as organic magnetic material, okay. And there are enormous research is going on this particular field, where triplet nitrines are actually used as a organic magnetic material, and this is very important aspect or very important applications in terms of triplet nitrines. Similarly, for singlet nitrines, as this can be used as a electrophile. So, this is having one empty non bonding orbital. So, it can accept electrons from other very easily. Many industrial and biological applications were there due to their ability to insert into a surroundings chemical bond. So, if there is any chemical bond which are having these electrons, so this is a electron deficient species, is wanted to take electrons. So, definitely what will happen, this can be inserted into that particular chemical bonds depending upon the situation, and that is why these can be used as a photoaffinity leveling agents, because once you can insert this, okay, if this, let us say this singlet nitrine contains some fluorescent part, okay, and then if this, after generating the nitrine, if it can be inserted into proteins, then basically we can visualize that particular protein as this nitrine that is having this fluorescent part that is there. So, we can actually now visualize these proteins, okay, and proteins through various fluorescence spectroscopy, and that way we can use these singlet nitrines for the photo affinity leveling agents. Okay. Sorry. Photo affinity leveling agents, okay. And number 2, they can be used as a to modify different type of polymers. So, modification of polymers, okay. So, this different type of reactions or different type of application is there for triplet nitrine as well as for the singlet nitrine, okay. So, we have discussed various applications of triplet and singlet nitrine. Thank you.